Does anyone remember from Algebra 1 or Algebra 2 or some class you were in what a function is? Okay, an equation with a variable. It relates usually two variables together. We could do height and shoe size, right? Those are any two variables that are related together is a function. But there's a little more to it than just any two variables related together. It's actually called a relation, and I'll put those definitions up later. But a function is one where a specific x goes to a specific y. The x is when you put something in, it has a specific output. I'll give you the definition of that. If f of x, so we have a function that represents the temperature in degrees Celsius of a cup of coffee over time in seconds. Does anyone, I'll give you the real definition in a second. Does anyone know what f of 3 means?
Oh, f of 3. F. Oh.
So
3 represents x.
Okay, 3 represents the x. The function is temperature. X is time in seconds. So f of 3 actually represents the temperature of the coffee. After 3 seconds. I don't know if we're warming it or cooling it or what's happening to it. But that f of 3 notation is the function when I put 3 in. So today we're going to break down what a function is, how it works, and all of that fun stuff. You've been using functions since you were in pre-algebra, and it's always one of the things that students have a hard time grasping. What in the world am I doing? So that's going to be our goal today. So I'm going to break down what's a function, what are we doing with it, why it's useful, why do we use it.
Well, they usually break.
Most of the time, no. I mean, functions usually will have like 3x plus 2. But we need to kind of break down what is that? What are we doing? So the first thing we're going to do is define a relation and a function. So a relation is a set of input and output values. Any set of input and output values. Height, shoe size, time, distance, time, any two things that we relate together is called a relation. There are no rules on a relation. It can be anything. Any x and y paired together. We still have some vocabulary words on a relation now, and there is an input set, and it's called the domain, and an output set, which is called the range. You typically call them x and y. You also may have heard them called the independent variable and the dependent variable. And I'm going to talk to you a little bit about what those mean. Before I define a function, I want to put yourself back in elementary school. If any of you have one of those Play-Doh boxes where you put Play-Doh in the top and you pushed a button and spaghetti came out the bottom, or a star came out the bottom, or okay. That's kind of what a function is. You put something in, and you do something to it, and something comes out. That's a function. So this little, I have a little, try to stick with the Play-Doh thing. A little box here, and I put in 3, it squares it, I get out 9. The square is the function, what's happening to it. So that's kind of what a function is. You put something in, you get an output out. The input is called the independent variable or the domain. It's independent because you get is paired with exactly one range value. What that means is it says the x's don't repeat, but when you put in an x, you get a specific answer out. Say you put in a 3 and it gave you 5 and 7. That's not a very good function. Functions are useful for predicting things. Say we did make a height shoe size comparison function. Well, the function, you put in a height and you pop out a shoe size. It wouldn't be very helpful if it popped out 5 different shoe sizes. It wouldn't give you any kind of predictor. So that's what a function does. You put something in, it gives you a specific thing out. Function as a relation. Okay, so we're going to look at multiple representations of a function. James asked here, we're going to look at these mainly in words. Actually, we're going to look at these 4 different ways. We're going to look at them in words, we're going to look at them in tables, we're going to look at them in graphs, and we're going to look at them in equations. That way we kind of get the full scope of what a function is. And those are just 4 different representations that we can have of a function. One representation is a mapping. This is called a mapping, where you draw arrows from one set to the other. And ask the question, is a set y a function of x? If they ever rearrange that wording, they're trying to trick you. And we'll talk about them rearranging that. But typically, y is the function, x is the input. Y is the function value, the output, x is the input. So it's asking, is y a function of x? Why or why not? So remember, the x's can't repeat. Each x goes to one y. So is the first one a function? Does each x give you one output value? Yes. 3 goes to 8. 4 goes to 8. 5 goes to 5. 2 goes to 4. They each go to something specific, don't they? So that is a function. Now, it did have a y value that repeated, and that's okay in a function. You could have a very boring spaghetti maker. Every time you put something in, it always gives you spaghetti. No matter what you did to put in, it gives you spaghetti, right? It's a function. It takes something in, it gives you something out. This one is not a function. Because you can't use it to predict. When I put it in a 5, I get a 2 out and I get a 9 out. So everyone see how that's not a function. So this one's not a function. And this one is. And your reasoning is the x's don't repeat. No, the x's do repeat. The 5 goes to the 2 and the 5 goes to the 9. The 5 is used twice. The x value is used twice. So that is not a function. Okay, so look at number 3. 3 goes to 2, negative 5 to 1, 4 to 3, 2 to 3. Is that a function? Yes. Why? The x's don't repeat. Right? So y is a function of x, the x's don't repeat. And let's look at number 4. Do any of those x's repeat? So it is a function because the x's don't repeat. Now, I just want to show you this. This is the only textbook I have ever seen this question in. It's not something I would expect you to see long term on the ACT or anything. They don't typically try to trick you with that. But I did see this textbook ask, is x a function of y? If they ask that question, they'd switch the input and output, right? And so they asked on number, I'm asking on number 3, is x a function of y? That would mean these are rearranged. And would that then be a function? Why not? Because the 3 repeats. So that thing, I don't like that question. I think it's a trick question. But it is trying to get you to think about which one's the function. The function value, the output value, or the y value. But again, if you see that question, it is a trick question that this book asks us. So. Okay, the next thing we're going to look at is how to find values in a function. You're really good at this if you have an equation, because y'all did that a lot in number 2. If you have an equation, how do you find f of 4? You plug 4 in for x, and you get a value, and that's how you find f of 4. But we need to break that down. What are we finding? We're finding the y value, aren't we? The output value of what that Play-Doh box did to us. Right? When we put in the 4, what happened? Well, we can also ask that question with a table or a graph. And so I actually have a table here. It says the table represents f of x. And it has -9 to -5, -2 to 2, 4 to 8, 11 to 5. So f of 4 is really asking, what is the y value when x is 4? And what is it on the table? And so I could ask it with a table, I could ask it with a graph, I could ask it with an equation, which I'll do in the next slide, but you're really good at that already. So this is a different way to look at it. So the 4 is the x value, f of 4 is the y value. So I asked you that at the beginning, and I thought maybe it was multiplication, maybe so what it really means, f of 4, what that notation means, it means the y value when x is 4, the function value when x is 4. So I look, and the y value is 8. Okay. So what about f of 2? I don't know. Agree? You ever heard the word undefined? What does undefined mean? It has not been defined, right? Would you agree on that table? F of 2 has not been defined. No one told us what it was. So f of 2 is just something that has not been defined. We don't know what it is. What about f of -9? The graph represents g of x, and you may need me to help you see where those points are. But it says to find g of 3. What is it asking? It asks to find g of 3. The y value when what? When x is 3. The y value when x is 3. So I'm going to look. When x is 3, where's the y value? At 5. If you can't see that point, it's labeled 3, 5. So it's the y value when x is 3. So g of 3 is 5. So I'm overemphasizing with multiple representations that g of something gives you the y value at that x value. Is that making sense? G of 0. -5, those of you in the back, you may not be able to see it. There's a dot down here at -5. So the y value at 0. What about the y value at -4? It's 1, good. If you can't see it, it's this -4, 1 point. So 1. Now this is an interesting question because it asks f of -9. Where would I go to find f of -9? Because this is g. This table is up there, right? And what is f of -9? -5. Divide by g at 0, which was -5. So that's an interesting question. Any questions on that? This is something they could ask an ACT. Something the ACT might want to know about that. Now this is a little bit more in our wheelhouse, our familiarity zone. We know how to do this, right? This is just another notation for the same, or another representation of the same thing we did on the last slide. We now have an equation for the function. I could graph that equation, couldn't I? When you plug in the 2 for f, that gives you the y value. When you plug in 2 for x, that gives you the y value when x is 2. So f of 2, I'm going to do 3 times 2 minus 2. So I'm going to put that 2 where the x is. But what it's giving me is that y value on the function, which is 4. 6 minus 2. So you find g of 7. Find g of 7. It's a big number. How are you finding it? Oh, we answer yes. How are you finding it? Plug in 7. Where at? Okay, now, I imagine some of you have asked the question, why do I use f instead of y? Well, sometimes we may have more than one function, and we might need to be specific. So the f or the g is actually kind of the name of it. You're saying plug it into this function, or this function, function f or function g. So it's a way to name different functions so that they're not all y. You can call it f, g, h. We have 10 different functions, and the name would tell us exactly which one to go to. So g of 7 is 5 times 7 squared minus 7. 49 times 5. Wait, what is the answer? 343 minus 7 is 336. Any questions about that? Are you squaring the 7 first?
Yep. Square the 7 times about 5 minus 7.
Okay, stop this. What is it? So I'm going to ask you that question. So, 4, 5. So, so figure it out. Alright, and f of 2 plus f, or g of 7, well I've already found f of 2 was 4. I found g of 7 was 238. So f of 7, f of 2 plus g of 7 is 3, or 2, 42. Any questions on that? Why is the what?
Where'd you get the 2?
The f of 2
On. Yeah, the first.
up here.
Right, it's the 30, 32.
I'm just going to put that 2 right here.
Oh, okay.